Hello YouTube, and thank you for watching. In my last video I had downloaded the Stack Overflow SQL database and migrated the data over to Oracle 21C. The database is about 50 GB in size and contains about 9 tables. The database is sufficiently large for the slow query to actually run slow, and I'll be using this database to demonstrate query performance tuning. I want to share the methods I use and the tools that I've developed over the years. Okay, so let's get started. The first thing I do when I look at a database is query the metadata and look for the number of rows in the tables. So here are the 9 tables. That's in the pstream schema, and here are the number of rows. Typically, the tables that contain small number of rows are lookup tables and contain static data. Tables that have a very high number of rows are the ones that are heavily modified and candidates for indexing. The Stack Overflow is a question and answer website. So the first question that popped into my head is, who is the user that posts the most number of questions? According to the documentation, the questions are in the post, and the post type ID column value determines if it's 1, it is a question. If it's a 2, it is an answer. So let us query and see who is the top user with the most number of questions. In the last execution, this query took about 37 seconds, which is unusually slow. The reason is because it's doing a full table access, which is essentially reading the entire table. If you have 1 million rows by 10 columns, it's going to read 10 million values in order to fetch the results. And this is the reason why it's taking so long. And here we go. It took about 37 and a quarter seconds to complete. The user ID 0 posted 112,000 questions. User ID 39677 posted 1,830 questions, and so on. Okay, so 37 seconds is rather slow, and what we're going to do now is look at the execution plan to see if we can improve the query. And the way we do that is we use a DBMS explain display cursor with the first column and the second column value set to null. And what this does is it fetches the execution plan of the last query that you had executed. So here at the top, what you'll see is the SQL ID and the child number. Here is the execution plan, followed by the predicate information. Predicate information is an advanced topic, and it comes in handy when tuning a very complex query. But for now, let's look at the execution plan here. The plan is read from left to right, from bottom to top. Now, this may have a lot of information for somebody who has never seen or unfamiliar with an execution plan. And what you need to do is focus on particular areas. The first thing here is look at the operations and look for table access full. This is where it's reading the entire table, going from left to right, top to bottom, reading each value that's in the table. According to this, it's reading 2 million rows with 18 million bytes, and the total cost of this total CPU cost is 975K. This may sound like uh, very complicated, but it really isn't. There is a method to systematically tune any query, and that's what I'm planning to show in this demo. Okay, so table access full suggests that we need an index on this table to reduce the cost of this query. Now what we're going to do is go back to the query. So the query has what's called a filter. In this case, it's querying the post table, filtering on post type ID equal to 1, which happens to be the question. So what we're going to do is create index on the filter. This is called a filter. And this is the syntax that we're using, create index on the pstream schema. The filter is the post type ID column. So let's go ahead and run this. The degree 4 allows the Oracle to build the index in parallel, which is a much faster operation. And the no parallel option sets this value back to 1. Let's run this query and see if the runtime is reduced. This time it actually took longer, taking 56 seconds. Let's see what happened here, because the index should have improved the query performance, but it actually has not. So this is the index that was created on the post table. You can see that the execution plan did utilize it. However, there is not much improvement, and the execution time actually took longer because the data had to be fetched from disk first. Subsequent execution should reduce the runtime because it'll reduce the disk I/O. However, this is not an improvement per se. The reason why I showed you this example is because indexes don't necessarily improve unless you have the correct index in place. Okay, so what we're going to do now is we're going to drop this index on the filter. we're actually going to do what's called a covering index. Now, covering index contains all the columns in the query. So here we see that in the post table, there's a post type ID column, which is in the filter, and the owner user ID, which is in the include column. So let's go ahead and create a covering index, and it's going to have the filter column and the include column. Okay. Okay, now that we have the covering index in place, let's go ahead and run this query again and see if it improves the performance. So here you've noticed that the query now completes in under 2 seconds compared to 37. Let's go see what happened. Okay, so here's the index on the post table, and you can see that the CPU cost has reduced from 975K down to 14K, which is a huge improvement. The runtime has reduced from 37 seconds down to about 2 seconds. Well, once you know the SQL ID and the child number, you can fetch the execution plan um, at any time by populating the first column and the second column as shown. So for example, here is a SQL ID child number. So if I wanted to fetch this at a later time, you can do so using this. Now, a lot of the times when you are in a production database, you don't want to be running queries. Rather, look at the query statistics. And the way to do that is to query the dynamic performance view, such as the $SQL. Here's a query that I use quite often, and it requires plugging in the SQL ID. So in this example, you can see that this particular query with a child number of 0 had executed once with an average elapsed time of 1,900 milliseconds with an average disk reads of 16K, average buffer gets of 16K, and this is the last time that the query was executed. Hope you found this information useful. I know this is a lot of information to absorb, and I plan on providing more details as in future videos. If you enjoy the content, please hit the like button and please subscribe. Thank you.